Mid-point theorem. Statement: a line joining midpoints of any two sides is parallel to third side and half of it. So let me take midpoints of these two sides. AB midpoint P and AC midpoint is Q, such that PQ is a line joining midpoints of two sides, AB and AC. Yeah.
PQ is a line joining midpoint.
PQ is a line joining midpoints of AB and AC. P is midpoint of AB and Q is midpoint of AC. So now if you join those two midpoints, you'll get a line segment, right? Line. Okay. That line is parallel to third side and half of it. So which means what to prove? What to prove? To prove PQ should be parallel to BC, first point. Second point, we need to also prove that PQ is half of BC. Then construction. Why do we need construction? Always construction requires where there is no direct approach possible, because parallel we need to prove, and to prove congruency also I cannot prove congruency of these two triangles anywhere. Clearly those are not congruent. So therefore we need some additional construction. We learnt parallelograms. That parallelograms concept I am going to bring it here. By that I will prove PQ is parallel to BC also and PQ is half of BC also. Let's see how can we do that. So for that construction, I am just trying to draw a parallel line. Just now we discussed drawing a parallel line from vertex to opposite side. See, from vertex C to parallel line we are drawing so that it is parallel to opposite side. See now, this is parallel to what? This is my construction. And extend PQ. When you extend PQ, it meets this line CP line, maybe CX line at some R point R. So draw CX parallel to AB. First point, that is what we drew. CX parallel to AB. This we just learnt in the previous sum. What is that? Take a triangle, draw parallels from vertices of to the opposite sides. See, this is the vertex and a parallel line you draw through the point a vertex so that it is parallel to the opposite side, and draw another parallel through B so that it is parallel to opposite side AC, and through A so that it is parallel to BC, like that. The same concept I am going to apply as well here as well. Okay. So the next point is extend PQ so that it meets CX at R. So produce PQ to meet CX at R. Let's talk about triangle APQ and triangle CQR, AQP and CQR. Let's observe these two triangles. Now proof. What is proof? Consider triangle AQP and triangle CQR. From these two, if you clearly observe, this one AQ is equals to QC. What do you say? correct? Given Q is midpoint, so therefore AQ is equals to QC. Then if you clearly observe, CR parallel to AP, correct? As CR parallel to AP, now this angle is equal to this angle. So QCR is equals to QAP. Okay, QCR is equals to QAP. Why? Alternate interior angles. So another angle I got. Go with the other angle. What is that? Vertically opposite angles. So angle AQP. No, oh, okay. Should have taken this first and this next. Why? Because we are talking about first APQ triangle and then this. So first talk about QAP and then QCR. So never change the order. First, if you talk about first triangle parts and corresponding to second triangle parts. Now AQP is equals to triangle. AQP is nothing but CQR. So this is what? Vertically opposite angles. So another angle also I got. Now by ASA congruency, triangle AQP congruent to triangle A with C, Q with Q and R with P with R. Okay, we got AQP congruent to CQR. This much we have got for now. Now what we do here? What is our main motto? We need to prove PQ and BC relation. For that, so if you can prove PBCR is a parallelogram, then PR and BC are equal to each other. And also if you can prove PQ is equals to QR, then PQ is half of BC indirectly. So that way, let us try to prove PBCR is a parallelogram. That is our next thing. When one pair of opposite sides are parallel and equal, then it is a parallelogram. Okay. So for that, here by CPCT, what we can say? By PQ is equals to QR, correct? And CR is equals to AP, correct? Therefore, already CR is equals to, AP is equals to BP, right? So can I also write AP is equals to BP? We proved CR is equals to BP as well. From BCRP, BP parallel to CR and BP is equals to CR, correct? So therefore, one pair of opposite sides are parallel and equal. Therefore, BCRP is a parallelogram, correct?
So which pair is opposite and equal?
BP parallel to CR by construction. BP is equals to CR by congruency. We proved CR is equals to AP. AP is equals to BP already given because P is midpoint of AB. So therefore CR is equals to BP. So now BCRP is a parallelogram for now. So that implies PR parallel to BC because opposite sides are parallel and PR is equals to BC, correct? Now PR parallel to BC means PQ also parallel to BC, no? because same line, no? Next, PR is equals to BC, then PR nothing but what? 2 times PQ, no? 2 times PQ is equals to BC, no? PR is equal to 2PQ, which is equal to BC. I want only PQ, so PQ is equal to half BC. We proved na both. So midpoint theorem, it is very, very important theorems in geometry. So it states a line joining midpoints of any two sides is parallel to third side and half of it. That is the statement. What to prove out of that? PQ parallel to BC and PQ half of BC we need to prove. What is given? AP is equals to BP, AQ is equals to QC. You should have written here given also. After statement, what is given? ABC is a triangle and P is midpoint of AB, so that AP is equals to BP. Q is midpoint of AC, so that AQ is equals to QC. Got it? Now construction. Directly we cannot prove, so we need a construction. So draw CX parallel to AB. And produce PQ. Anyways, we have PQ line. Let us produce PQ to meet CX at R. So PQ meets CX at R. Now we have got PCRP is a quadrilateral for now. For now it is just a quadrilateral. We are not sure it is parallelogram at. So now what we are going to consider? Proof. Consider this triangle, this triangle. What is it? AQP and CQR. We are going to consider. If we consider those two, and AQ is equal to QC anyways from the two triangles, because Q is midpoint of AC, so that AQ is equal to QC. So one side we got. Next, QAP is equals to QCR, alternate interior angles, because already we know CX parallel to AB, so that CR parallel to AP, and hence it is these two are alternate interior angles because AC acts as a transversal here. Okay, so one angle we got, so one side and one angle already we got. Next, AQP is equals to CQR. AQP is equal to CQR, where vertically opposite angles, because these two are straight lines. Remember, these two are straight lines, that's why vertically opposite angles. Otherwise, this is a straight line, but other is not a straight line like this, then these two are not equal. Both should be straight lines. Now AC is a straight line and PR is a straight line, therefore these and these are vertically opposite angles, so are equal. So we got another angle. So if you clearly observe, angle side angle, angle side angle, by angle side angle congruency, ASA congruency, we can say AQP congruent to CQR, AQP congruent to CQR by CPCT, which is corresponding parts of congruent triangles. PQ is equals to QR, these two sides are equal, and also CR is equals to AP, CR is equals to AP, that is equals to AP nothing but BP, so indirectly CR is equals to BP. Okay, so now what you got? PQ is equals to QR you got, and CR is equals to BP you got. Just observe from quadrilateral BCRP. From quadrilateral BCRP, BP parallel to CR by construction only. BP parallel to CR through construction, and BP is equals to CR. Now we got by congruency, B and congruency and midpoint. So BP is equals to CR. So we know one pair of opposite sides are parallel and equal, then the quadrilateral is called as a parallelogram. So BCRP now acts as a parallelogram here. If it is parallelogram, then other two side, other pair of opposite sides are also parallel and equal. So therefore, PR other side and opposite, other pair of opposite sides. PR parallel to BC and PR is equal to BC. And here PR is nothing but PQ plus QR, and PQ is equals to QR already we proven. So here PR nothing but 2 times PQ. So I just replaced here 2 times PQ is equals to BC. But we want only PQ. PQ is equals to half BC. Now if you see this statement and this statement, PQ parallel to BC, one statement we proved here, and PQ is equals to half BC, and we proved the second statement as well. So that is it. Got it? So finally what it is? if a line joining midpoints of two sides, that must be parallel to third side and half of the third side. This is called midpoint theorem. Very important theorem. Please make a note. Thank you.